Welcome to Daring Marine YouTube channel. Today we will be discussing about burner used in marine boiler. What are the different types of burner that we use in marine boiler? So, the main purpose of a boiler burner is to break the oil into fine droplets. That means to atomize fuel in a correct manner so that efficient combustion can be achieved. Okay, boiler burner means their main purpose is to break the oil into fine particles, that is fine droplets. That is to atomize fuel in a correct manner so that efficient combustion can be achieved. Marine boiler can be of three types. They are pressure jet burner, air or steam blast atomizer, rotary cup burner. Okay, three types burner: pressure jet burner, air or steam blast atomizer, rotary cup burner. Pressure jet burner means this is the simplest and most common design of burner. Pressure jet burner is the most simplest and commonly used burner. Atomization of fuel is achieved by forcing the fuel under pressure through an orifice at the end of burner. So the pressure energy in the fuel is converted to velocity here. So here the atomization of fuel is achieved by forcing the fuel under pressure through an orifice at the end of burner, and pressure energy of the fuel is converted to velocity. Here a spin is given to fuel prior to the orifice, imparting centrifugal force on spraying of fuel, causing it to atomize. Here the spin is given to fuel prior to the orifice, imparting the centrifugal force on the spray fuel, causing it to atomize. Okay, pressure jet burner. This is the simplest and most common design of burner. Most common design of burner. Here, atomization of fuel is achieved by forcing the fuel under pressure through an orifice at the end of burner, so that the pressure energy is converted to velocity. So the spin is given to fuel prior to the orifice, imparting the centrifugal force, so that spray of the fuel it will cause to atomize. Here, the fuel pressure required for a pressure jet burner may vary from 7 bar to 15 bar depending upon design of burner and load of boiler. Okay, the fuel pressure required for the pressure jet burner may vary from 7 bar to 15 bar depending upon design of burner and load of boiler. Maximum required viscosity of boiler inlet is normally 15 cst, and both diesel oil and heavy fuel oil can be used as fuel. Here the maximum required viscosity of the burner inlet is normally 15 cst. Both diesel and heavy fuel oil can be used as fuel. Okay, the fuel pressure required for a pressure jet burner may vary from 7 bar to 15 bar depending upon design of burner and the load of boiler. The maximum required viscosity at the burner inlet is normally 15 cst, and both diesel and heavy fuel can be used as a fuel. Then the disadvantage of this burner is the low turn down ratio, that means between the region of 3.5 and down. The advantage is that it does not require any assistance other than supplying fuel at correct pressure. Okay, disadvantage is that low turn down ratio. So in the particularly in the region of 3.5, advantage is that there does not require any particular assistance. Only do we have to do is supply the fuel at a correct pressure. Here is one picture of a pressure jet burner. Cap will be the orifice. So they will get a pressure energy will convert into velocity, so that oil will get atomized into fine atom breakdown to fine atomized in the nozzle body and all. Then air or steam blast atomizer. This type of burner is similar in working as a pressure jet burner, but here we have addition of a high pressure steam supply arrangement incorporated in it. Air or steam blast atomizer means this is the type of burner similar in the working of a pressure jet burner, but here we have addition of that addition property means we have addition of a high pressure steam supply arrangement incorporated with it in it. The oil is thus sprayed in the path of this high pressure air or steam, which helps the fuel for atomization. Normally air is used during the initial starting of the burner, and then steam takes over the operation. Okay, here oil is thus sprayed in the path of high pressure or air steam, which has the fuel for atomization. The high pressure oil is thus sprayed in the path of high pressure air or steam, which helps the fuel for atomization. Normally air is used during the initial starting of burn, then steam takes over the operation. Okay, here the air or steam blast atomizer. This type of burner is similar in working of pressure jet burner, but with the addition of high pressure steam supply arrangement incorporated in it. Here the oil is sprayed in the path of high pressure, so that air or steam which will help the fuel for atomization. Normally air is used during initial starting of burner, then steam takes over the operation. The steam set has tangential nozzle which provides rotary motion to fuel to ensure efficient combustion. So the steam set will have tangential nozzle to provide rotary motion, so that to ensure the fuel having efficient combustion. Here we can say it is the air or steam economizer. Okay, then rotary cup burner, as the name suggests, This burner comprises of a burner nozzle which is covered by rapidly rotating cone. So the rotary cup burner, there will be a burner nozzle which is covered by a rapidly rotating cone. There will be a burner nozzle covered by a rapidly rotating cone. Fuel oil is carried onto a nozzle. Fuel oil is carried onto a nozzle which is centrally located within rotating cone. Okay, fuel oil is carried to a nozzle which is centrally located within a rotating cone. As fuel oil moves along the cup, due to absence of centripetal force, when fuel oil moves along the cup due to absence of centripetal force, oil will become thinner in its course as circumference of the cup increases. So when the oil, as the fuel oil moves along the cup, when the fuel oil moves along the cup due to absence of, when there is no centripetal force, then oil film becomes thinner in its course and circumference of the cup will increase. Ultimately, the fuel is discharged from the tip of rotating cone in the form of a fine atomized spray. Okay, here the principle is burner consists of a burner nozzle which is covered by a rapid rotating cone. Okay, fuel oil is carried onto a nozzle which is centrally located within a rotating cone. As the fuel oil moves along the cup due to the absence of centripetal force, oil film becomes thinner due to course of circumference of the cup as the circumference of the cup increases. Ultimately, the fuel is discharged from the tip of the rotating cone in the form of a fine atomized spray. The spinning cup will offer some advantages. There are wider turn-down ratio with lower excess air. Here, wider pressure jet burner, the turn-down ratio is less. Here, turn-down ratio is high with lower excess pressure and lower excess air and low O2 levels, low oxygen levels, and no requirement for atomizing air or steam. Low fuel pressure requirements to an extent that gravity flow is sufficient. Here, low fuel pressure is required to an extent that gravity flow is sufficient. Stable flame achieved with very low fuel flows and maximum flow limited by size of cup. Here, but stable flames is achieved with very low fuel flow, although maximum flow is limited by a cup size. This allied is being limited to side fire making. The design is more suited for smaller installation. Okay. This rotary cup burner design is very limited to smaller installation and all. Here the advantage means the spinning cup of the rotary cup burner, they have certain advantages means wider turn down ratio with lower excess air, low oxygen level, no requirement for atomizing air or steam, low fuel pressure requirements to extend that gravity flow is sufficient, then stable flame achievable with very low fuel oil flows through maximum allowed limit even though maximum allowed flow is limited by the size of cup. Then this is allied being limited to side firing making design more suitable for smaller installation and all. Here is the picture of a rotary cup burner. The electric motor driving spinning cup via belt and primary airflow. The spinning cup is there. Then fuel flow control one. Pilot or ignition burner. In some marine burners with the main burner firing in heavy fuel oil, it is very difficult to initially start the boiler with the main burner. Yes, we understand that. We know that main burner is firing in heavy fuel oil, so it is very difficult to initially start the boiler with the main burner. For startup of the boiler, a separate pilot or ignition burner is provided, which uses diesel oil as fuel. Before startup boiler, a separate pilot or ignition burner is provided, which uses diesel oil as a fuel. This enables pilot burner to ignite even at the coldest condition of ship phase at sea. So this enables the pilot burner to ignite even at the coldest condition of the ship at sea. Okay, means pilot or ignition burner means in some marine boiler, the main burner is firing with a heavy fuel oil. So it is very difficult to initially start the boiler with main burner. For startup of this boiler, a separate pilot or ignition burner is provided, which uses diesel oil or as a fuel. This enables pilot burner to ignite even at coldest condition of ship phase at sea. The pilot burner has separate diesel oil piping and pump. The pilot burner will have separate diesel oil piping and pump. The heat source is provided by two electrodes igniting the pilot flame. Which are fitted to a high voltage ignition transformer. The pilot burner is allotted with a limited period of ignition. During which it acts as a source of heat. For main burner. And once the time is over, the pilot flame goes up. Okay, the pilot burner has separate diesel oil piping and pump. The heat source is provided by two electrodes igniting the pilot flame, which are fitted to the high voltage ignition transformer. The pilot burner is allotted with a limited period of ignition during which it acts as a source of heat for main burner, and once the time is over, the pilot flame goes off. Okay. Thank you.